Matthias Wissert is head of R&D at Trumpf. In this role he oversees research and development for both the company's metalworking machines and the laser division, the one that supplies ASML. Over his 12 years at Trumpf, Matthias has witnessed a cultural shift, driven in part by the collaboration with the Dutch litho company. Matthias believes that much of what Trumpf's engineers have learned from the collaboration with ASML can also be applied to its own machine development. I started by asking Matthias about his first encounter with ASML.
Well, my first encounter with ASML came a few days after I started at Trumpf, which was 12 years ago. So since we were at that time during the tests of our first generation of serious systems, we had intensive technical discussions on the specifications, and yeah, that's when I quickly got used to the way ASML worked and was already at that time very fast, also impressed by the way they pushed things forward.
At that time it was still Cymer, isn't it?
At that time it was already ASML, so ASML had acquired Cymer quite recently, I think 1 year earlier. Okay. But of course Cymer was still playing a more significant role at that time in the discussions with Trumpf, with ASML gradually taking more and more ownership on the discussions due to the acquisition. I think one of the first big discussions I witnessed was one of the so-called interface meetings that we regularly have with ASML. That is about every 2 to 3 months we have the technical ownership teams of both sides make sure that we're well aligned on what our current goals are and what we need from a mostly technology point of view, and yeah, that's where I also, in a bigger setting, so it was at that time about 30-40 people in a room, I realized how that discussion is led by ASML, where they're interested in the details and where they just confide in that Trumpf will do the right thing, and what that then means for our product and how we should develop.
Yeah. So what is the setting and what's happening
in that meeting? So basically, it's mostly us who present the status on various technical aspects, so projects and sub-projects, where, for example, we would say how we solved at that time a specific issue when coupling our system to the full source, where you'd have backward propagating light, for example, that we could not test in our facility and then jointly discuss, okay, so what will you do? Can you test that still at Ditzingen? Do we have to do additional tests in Veldhoven? What are the teams that can do that? Mm-hmm. So that's more on a higher level, but then it would also really go into the details. Okay, we are seeing this specific effect. Trumpf, have you understood why this is there? We actually need, to take an arbitrary example, the beam shape a bit differently. So how can you influence this? What are options? And then we would do sort of a start of a technical discussions, but then once the problem statement was understood, of course, then take that afterwards to the larger technical teams and continue really understanding how far do we have to go, what is needed, make the balance between effort and what we can do. And of course we have to keep in mind that at that time the development team at Trumpf was not the 500 people we're today, but we were about 50 people in R&D who had to solve those challenges. So it was a very different, and out of those 50 people, about 10 to 15 people of Trumpf would be in the room. So actually 1/3 of the team was informed the moment the meeting happened. And today that would of course be, those meetings still exist, which is interesting. And it's still about the same number of people who participate, but then it's a much bigger organization on both sides that would deal with that outcome.
Yeah, you were new at that time in the company. How would you define at that time the Trumpf culture and the ASML culture?
At that time, there were still much more noticeable differences than we see today in the way we approached development. And so one key thing about ASML culture that was already present at that time, of course, at ASML, was that they'd ask for a clear plan forward with clear milestones and also scenarios on if your plan A goes wrong, what will your plan B be? At Trumpf, we were rather used to very quickly choosing the best solution based on the input of various experts, and that typically would be a very good solution. However, if you do that, there is of course always a remaining risk that in the beginning you have overlooked something because you had to choose very quickly. The advantage was at that time the pressure was high to bring a system into the market. It's still high today, but it was much higher at that time because we had to prove we could reach a certain threshold of EUV power. And that meant that we would tell ASML that this is our approach and this is how we will do it, and that they could come back in a few weeks or months and we tell them how far we are.
Were they convinced?
I think they were already at that time, if not we wouldn't cooperate, convinced that Trumpf had a very high knowledge of the CO2 laser technology and also the system we were building. However, they did not like at all not having a target date and those milestones. So, and that is something where we continue to have discussions on that we should make that more efficient, because we basically had a plan that ASML could not work with internally. And
why didn't you have those milestones? Why didn't you have that roadmap?
Because, as I said, we had a very limited team and also a culture where Trumpf was used to from other projects that we were the big company and other companies waited until we were done, because that is what smaller companies, if you look at the tooling machine industry, Trumpf would develop a machine independently and then there would be a market introduction date. And if we had to shift that market introduction date, we'd shift it and the companies would still buy because it was the best solution. So that was what we were used to. And now it was the other way around. We had a customer that was very conscious about what they needed, but we needed time as an organization to learn that this meant that we also had to not only maybe have a better planning, but also to be better ourselves in doing that planning. And the bigger the team grows, of course, the more important this challenge then becomes.
How was ASML putting that pressure on you?
I think that also changed over time. So with our technology becoming mature, and I think key things happened around 2018 when we reached a certain EUV power threshold, and it was clear that this was the technology to be, and this was going to be in many fabs around the world. I think also at ASML that push for those plans got even stronger. So in the beginning they'd say, well, please do something, and then we'd still work the way we did, and they accepted that to some extent. And then the bigger the business became, the higher the turnover became, the less acceptable it was, because it didn't work in the ASML reporting system, where they also, within EUV, I think, which in the beginning was a research project, became the project for the future, the technology for the future. And so it was a gradual increase and push. And I think that went up to from 2018 to about 2019, 2020, when there was indeed a rather big clash where ASML made very clear in a high-level management meeting that we couldn't continue in that way and that we needed to step up to fit how it worked with their suppliers.
So what did you have to do? Did you have to change your organization?
It was a mixture of many things. And ASML was fairly open to finding the best solution with us. So they didn't clearly dictate, okay, you need to do A, B, C, D, and E, and then we'll be fine. But they said, you need to make sure that you're now ready to change and discuss with us what we need, and then jointly find the best solution. And I think there are two key words to this. One is the so-called one company approach. Think about the problem we have as if we were one company, and then find the best solution for various topics. So how do we want to bring transparency to those milestones? Which competences does Trumpf really need, and which parts of the work will ASML do now and in the future? And then, of course, one topic was the question of how do we start and end an R&D project jointly, and what is our systems engineering approach to bringing the technology to the right level?
And on what level were you able to discuss your technology and IP openly? I know from the past that the protectionism of Zeiss concerning IP with ASML hindered the developments actually, because Zeiss was very protective, and there were a lot of instances where Zeiss had to put the problems on the table, and where ASML was able to help and really got things going forward again. How is that within Trumpf? Are you always putting all your stuff on the table?
I think one fundamental idea of that collaboration is indeed to put things on the table as openly as possible, which then also meant that we set up a strategy on how we apply for patents, in which cases we do that separately as Trumpf or as ASML, and where we have joint patent applications. So there are rules that we set down for those cases. And then, of course, there are some technologies where we say this is, and that's the most difficult part for us, this is core competency of Trumpf also outside the EUV business. And there, of course, we have to be very protective because it concerns then other markets. And there we find individual solutions if such a situation arises. But that has also become less frequent because the system that started 15 years ago, more or less from standard Trumpf components, which were then adapted to the EUV challenge, has more and more grown into best solutions for EUV-specific solutions. So it's very rare that we're actually using technology that overlaps with other Trumpf subsidiaries in a substantial way where that IP reason would be.
Yeah, but your laser division does service other customers.
Yes, we still sell CO2 lasers individually, but this is then only one so-called power amplifier that is used as a standalone laser, which we use 4 times in the EUV system. And it has, in many aspects, even though some parts are shared, different aspects. And also, and I think that's an interesting part, if you look at the history of the CO2 laser, the growth that we had with ASML overlapped with a significant decline of the usage of CO2 lasers for cutting purposes. Yeah. So in the end, in the beginning, we had a few CO2 lasers for EUV and many standalone CO2 lasers sold outside, and now it's the inverse. Yeah.
Now it's all this automotive, etc. market is serviced by YAG lasers.
Yes, or other solid-state solutions. Yes. And there are still some specific applications where CO2 is the choice, but it's becoming less and less frequent.
Yeah. And just curious, where do the very powerful, to what markets do the other powerful lasers go?
Well, I'll give one example, and that is ablating of material on a surface. So if you want to take away color, for example, from an airline jet, and you need to repaint it, then, for example, CO2 laser is very helpful due to the wavelength to clean that.
Not for tattoos.
For tattoos, you'd remove, unfortunately, a bit more than the tattoo, which is not something you'd like to do.
Maybe you can tell me more about the change of the cultures. First, you had actually 2 different cultures, ASML and Trumpf. How did they come together? You already told me about it, but maybe you can give me some more flavor.
So I think, again, let's put it that way. Of course, already in the time between 2013 when I started and 2020 that I mentioned as a step change in that collaboration, we adapted. So we understood better what terms of documents are needed, what needs to be transferred, but it was really a learning by doing without specifically talking about why you're changing.
Yeah, and why was Trumpf able to adapt?
I think the key question first is you have to acknowledge that you need to adapt. And that's what we most specifically did then in 2020. Why was Trumpf able to adapt earlier? I think because we had a very good hiring strategy, in the sense that we brought in people who were technically curious, who fit the basic principle of the ASML culture, which is you need to want to drive things forward and bring the best technical solution. And that is, despite cost challenges, despite everything where you need to adapt to the customer, that's the basis of both companies. And that's, I think, why that basis made it possible that we could adapt also to other aspects of the ASML culture, because that fundamental thing is there in both companies. You have people where eyes light up if they think about the product they work for, and that's amazing. And then you get about all those organizational aspects. And I think Trumpf is used to working with big customers also from the past, and now we had to get used to that one specific customer step by step, and we knew how to do it, but we needed, I think, to be faster than other corporations, because at the same time we also brought on board many people. I mentioned that we grew from 50 to 500 people, so all of these needed to absorb that while also learning the technical skills. And that's why we said, okay, we cannot only do that organically, but we need to put a project in place, an organizational project, which we called the R&D collaboration, where we then, with that one team aspect in mind, set up to change specific aspects. And one thing we worked on was specifically what are the competences that, for example, a mechanical development engineer, an optical development engineer, needs to have in mind when he makes or she makes their decisions. So that we look at specifically how does it work in ASML guidelines. So we shared, for example, design guidelines, said, okay, this is how they think. So does it make sense that we do it the same way? And also sometimes, if it didn't make sense, actively check what do we want to do differently and also write that down. Mm-hmm. And we did that really competence by competence. I think that was one important aspect. The second one was that really that systems engineering approach, where we said, okay, we need to think a system more holistically from the start. So get away from that, let's just start with very smart people, but very quickly. But let's take some time. And I think that's something, if people at the university look at the V model, that's always what you get. So they explained that to me at university. You need to put the effort in early to save time later. Yeah. And that's always easy written down and difficult to do, because there's always pressure and people get the impression that you're faster when you don't do that. Yeah. But during that R&D collaboration, we really took the time and said, okay, what are the people we need who believe in that sort of concept, who are willing to be architects, that's what we called them, and Jonathan is one of them, where we think they believe in that concept of taking time and opening up the solution space. Mm-hmm. And opening that solution space is, for me, the basic secret, and it's very basic if you do it, to then be able to choose actively which level of risk do you want to take. Mm-hmm. Because there may be three approaches. Everyone has their advantages and disadvantages on the cost, in the cost area, in the functionality area, in the timeline. And then you have to start making adoptions and iterate, and I think that's the second secret, which is also embedded in the V model, with your customer on what is the best solution at this point in time. And this will develop. And you have to get used to setting baselines, but not accepting them as the holy grail, but accepting them as the cup of today and ready to change if needed, but not too easily. And that's
this is actually a system engineering or a system architecture attitude, which is getting more and more important for the success of companies in general, I guess.
Yeah, and that's my feeling, that type of activity is, of course, especially important when you work with directly with one customer, like we do with ASML. But indeed, using that approach to then think about your product portfolio and strategy for the next 10 years holistically, also in other areas, to be able to both have customized setups for individual customers, but also a basis for your system where you have general modules that are reused in all types, and use that as part of your strategy. And I see that more and more also in other industry, that's what's needed.
Yeah, the revenue of Trumpf is now 5 billion euros. EUV business is now 1/5 of it. Do you think this subject is important for the other 80%? It's probably critical for the survival, probably.
It absolutely is, and I think the bigger the customers are you work with, the more important it gets, because the bigger customers, they have special wishes, and if you want to be a technology leader, no matter in which field, you have to be able to easily answer to those extra wishes without spending too much money on them. So you have to be prepared, which means you need to know your market, you need to know your customer, and merge that into that systems engineering strategy.
So companies who adapt to that will be the ones who survive or have success.
I assume if you have the right niche, you can still do it otherwise, but even then, if you do it that way, you'll be even more successful than you could be without that attitude. So we had once Bert Cook, who was at that time one of the key financial people at ASML, told us, and we asked him, what's the one advice you would give to Trumpf? And he said, listen to your customer. And it's as simple as that. And no matter whether it's technology, whether it's market, and of course we will then rightfully say even ASML is not one customer, because they're so big that they have many wishes that you have to consolidate.
And sometimes ASML takes decisions, like Apple, because they know what the customer needs without the customers telling them.
Yeah, and that's also, of course, our ambition, and we sometimes also have to do this. Sometimes ASML may not be able to tell us what they need, and still we have to make a choice, because if you think about the overall system, then typically we will have to start our development, and that's also true for our current draft laser generation that we're developing. You have to make some decisions without the final information from your customer. And we will tell ASML that we need that decision, but sometimes it will not come. And then we have to take that ownership and say, okay, this is now the baseline we will work with, unless you have a better one for us. And of course we try to then be able to adapt later on if something changes, but that's also something, a risk you always have to take, of in the end understanding your customer better than he does himself. And ideally you're right when you do that. Sometimes of course you fail, and then you have to do some rework, let's be honest.
Thanks for listening to the Bits&Chips podcast. It was really great to have you with us today. If you enjoyed the conversation or learned something new, please give us a thumbs up. It really helps others to find the show. And while you're here, make sure to subscribe so you'll never miss our next episodes. Thanks again for tuning in, and we hope to have you with us next time.